And most of the topics on this test would be, of course, repeated on the final. So we are almost done. There is a couple of more technique of integration that we talk about it after your test, and we are done. There is one more method for integration, and then we done. Okay. So this is going to be the one that I posted for you. Practice test number practice test number 3. It's going to be differentiation and integration. Differentiation is going to be mostly regarding the exponential function and the ln function. Okay, that we did, and an introduction to the notion of the integral. We give you 2 questions on the integral. Okay, so we start with the, so this is going to be your practice. Okay, practice test number 3. Question 1 is going to be differentiation. You want to differentiate mostly, it's going to be ln function, okay, and the exponential function. So you want to find the derivative of each function. Okay, the derivative of each function. Okay, each function. So the formulas that we need to know is derivative of ln x is 1 over x, and derivative of e to the x is just e to the x. But if you change it to something else, derivative of ln u, you have to apply the chain rule. It's going to be u prime u. If you change this one into the e to the u, derivative would be e to the u prime. Okay, this is all we need for doing these type of problems. So we go with the first part 1, y equal to 5x to the third, 5x to the third ln x is the product of 2 functions. So the first function is going to be 5x to the third, and the second function would be ln x. So we have to apply the product rule. Derivative of the first times second. Okay, derivative of the first one times the second function plus derivative of the second function times the first one. Okay, so there you are. Y prime, derivative of the first one, just a power rule. 3 times 5, 15, 15x squared times the second plus derivative of the second times first, derivative of ln x, 1 over x times the first one, 5x to the third. You have to simplify it. You can simplify these two, 1x out, that give you 5x squared. So the final answer, y prime is 15x squared ln x plus 5x squared, and you're done. No simplification is possible, okay? So this would be the end of the problem. The only simplification that you do for us is going to be this part over here. Okay, any question? So that's a tag 1. We have a very similar one for the exponential function, part B. In part B, you have a y equal to the x to the third, e to the negative 3x. Again, it's a product of 2 functions. The first function is x to the third, and the second function is e to the negative 3x. So product rule, derivative of the first one, 3x squared, times it by the second one, e to the negative 3x, plus derivative of the second times first. Derivative of the e function is just the e function, e to the negative 3x, but times it by u prime. U prime would be negative 3. Okay, exponential function never change, but you have to multiply the derivative of the top. So times it by the first one, times it by the first one. So you simplify it if it's possible. So it's going to be 3x squared e to the negative 3x. And over here, it's going to be minus 3x to the third and e to the negative 3x, and you're done. You can't do any simplification for this type of problem because there's no like terms, and this would be the end of the problem. Okay, that's part B. Any question?
Professor, can you explain how you got the -3 in the second part, please, again?
U prime, that's it. Derivative of the e function is the e function times u prime. Derivative of the negative 3x, negative 3. And this is your formula.
Okay, I see.
Okay,
Thank you.
very good. So that's a B. Part C, C is a standard one. C is y equal to x to the 6. Okay, it's kind of ordinary function, negative 3 ln x plus 7 e to the x. Just a combination of all the 3 types of function that we have: the power function, ln function, and the e function. Okay, so the derivative would be just derivative of x to the 6 would be 6x to the 5th minus, it's a number, so you're not going to use a product rule. It's a 3 times, it's going to be 3 times the derivative of ln x. Derivative of ln x is 1 over x plus 7 times, again, you are not going to use product rule. It's going to be 7 times the derivative of e to the x, but the derivative of e to the x is just e to the x. See, no changes. So, you know, if you like, you write y prime equal to the 6 x to the 5th minus, you multiply this, 3 over x plus 7 e to the x. Done. Any question? There's nothing special about this one, but I just want to remind you that if you know, if you have just kind of ordinary function, no product rule, no quotient rule, okay, no chain rule for this one. Okay, so that would be part C question. Part D. Part D, just a straightforward chain rule for the e function, e to the, okay, it's probably x squared, just check it so I can see it. Yes, e to the x squared, okay, x squared minus 5x. Again, it's like e to the u. You see, anything other than the x, you consider it to be u, and you have to apply the chain rule. So y prime, e function is going to be e function, x squared minus 5x, but u prime. Your prime derivative of the top, derivative of x squared minus 5x would be simply 2x minus 5. Can't do anything about it, so we just leave it. You can switch it if you like, but you have to keep this parenthesis. Okay, any question? So you have a similar one in your book. You just wanted to know. And the last one is just the chain rule for the e function, ln function, y equal to ln of what? 2x cubed plus 7x. Again, it's not the ln of x, so it's a kind of ln of u. Derivative of ln u, u prime u, u prime u. So this is how we're going to apply that formula. So I write it down over here. So y prime is going to be equal to, we get a quotient, u prime. Derivative of the inside. Power rule, 6x squared plus 7, that's going to be your u prime. Divided by u, so 2x cubed plus 7x. No simplification is possible. That would be the derivative of your function. Okay, u prime u. Any question? So that's a differentiating, you know, exponential function and the ln function. We give you one question, just a couple of parts of this type of function. You have all the facility, all the possibilities. There is no other type of the function, so you should be able, you know, to do it for us. Okay, so that's question number 1. Question number 2, optimization problem for the ln function and the e function means a function would be given to you, it may ask you to find the maximum or the minimum. So as usual, you have to find the critical points. Then you have to drop the critical numbers in your function. Then you have to test it. You may use the first derivative test or the second derivative test as you want or as you think that's going to be better one. Okay, so we take the first one. It's going to be question number 2. Okay, 2 optimization problem for the exponential function. Then you have one optimization problem. You get a couple of them over here, but we give you one from each. Okay, so we have quite a lot. So number 2, the function is f of x equal to f of x equal to 3000 x e to the negative 0.04x. You have a restriction. The restriction is that the x is positive, because they ask you to find the absolute minimum of this function, okay, on the interval of 0 and infinity. So the domain is going to be, the domain is given to you is 0 and positive infinity. Otherwise, the natural domain of this function is all real numbers, you know that, because of the exponential function. So you want to find the absolute maximum of this function, you have to differentiate it. You have to find the critical number first and then test it just using those tests that we have. Okay, so we differentiate. F prime of x is the product of two functions. You must be careful because of the x. So the first function is 3000x. This is going to be your first function. And this exponential part is going to be your second function. So we have to apply the product rule, derivative of the first times second, second first. Derivative of the first one, derivative of 3000x would be simply 3000. 3000 times the second one, e to the negative 0.04x. Okay, that's derivative of the first times second, plus derivative of the second times first. The second one is exponential function. So exponential function is exponential function, e to the negative 0.04x, but u prime. U prime derivative of the top. Derivative of the top simply is going to be negative 0.04. Okay, so that's going to be the derivative of the second one. It's exponential function. Exponential function would be exponential function. But since this is not x, it's something else, you have to multiply by u prime. Now that's the derivative of the second one, times it by the first one. The first one, 3000x. Okay, the product rule carefully. Derivative of the first, derivative of the 3000x would be 3000 times second. Plus derivative of a second times first. Second one is exponential function. Exponential function never change, but you have to multiply by u prime. That's the derivative of a second times first. Now we have to simplify it. We have to multiply these two together. It's a monomial, put it up in front. So a little bit of algebra. So this is going to be 3000 e to the negative 0.04x. Now we multiply these two together. 3 times 4 would be 12. With 30, but we have two decimals, so it's going to be minus, okay. And that's it. It's going to be 120. 120x e to the negative 0.04x. Okay, I'll multiply this together up there, put it up in front to get this number. And now, since you want to let it equal to 0, solve this equation, we already talked about it. There is always a common factor over here. There may be quite a lot, but what you are going to do is you have a chance to take this exponential out. You take it out, that make it easier to continue. So if you don't take it now, you have to take it out later on. So we continue. F prime of x is equal to the e out, e of 0.04x. So the leftover is going to be 3000. Okay, minus 120x. You see? When you put it out, this would appear nicely, and then when you let it equal to the 0, you'll be able to solve the equation right away. Okay, we let it equal to 0 because we are looking for the maximum and the minimum. Now you have a product of two functions equal to 0. So each one should be equal to 0, or one of them must be 0. So for the first one, e to the negative 0.0 for x equal to the 0. You know that the exponential function is never 0 because of the e. E is 2.7. You'll never be able to make it 0. So this would be a contradiction. So you get no solution from this one. But if you let the second one to be equal to the 0, see the second one, you solve for x nicely, and that gives you your critical number. Okay, it's going to be negative 120x equal to the negative 3000. So your x would be, it's like 3000 over 120. Okay, negative 3000 over negative 120. Okay, you simplify it by 10, that gives you 300 divided by 12. Okay, and if you divide it, I think that gives you 25. Okay, so your x would be equal to 25. So the critical number is 25. Okay, that's going to be what? Any question? So that's a nice algebra involved. Okay, nice algebra involved, and if you take the derivative all right, there is always a chance to pull out the exponential factor out. You pull out the exponential factor, this is a product equal to the 0. So either the first one is 0 or the second one. This first one is never 0 because it is 2.7. Exponential function never 0. So you solve the second one, we get the 25. Okay, that's what we want. Okay, that's it. What's the question? How did I get 120? How did I get 120? I multiply. You see, you multiply this one. 3000 times, okay, 0.04. 3 times 4 would be 12 with 3 zeros. You have 2 decimal places, you simplify it 120. Any more question? No, we are not done, of course. This is the critical number. So what you are going to do, you are going to test it. Okay, you test it to see whether it's going to be, you can drop it back into the function and then test it, in case you will forget that one. So go back to the original function, substitute. So what's going to be f of 25? This is just a candidate so far, not the answer. Okay, we go back to the original function. This is it. And you replace the x by 25. So what's going to be the result? It's going to be 3000x, 3000 times 25 times e to the 0.04x is going to be negative 0.04x, but x is what? X is 25 now. Okay, 4 times 25 would be 100, but you have 2 decimal places here, so it's going to be 1. So it's going to be equal to 3 times 25 would be 75, so that gives you 75,000 e to the, okay, e to the negative 1. E to the negative 1. So we rewrite it, no negative power, you know that. So you rewrite it as 75,000 divided by E. You can use your calculator if you like to find the actual number. And if you write it down in this format, of course, we accept it. Okay, so this is the candidate. Now you have to determine whether this is going to be, you are being asked to find the absolute maximum. So you have to show that this is a maximum. Now how are we going to do it? We have 2 choices, remember? So testing. Testing for x equal to 25, the critical number. You have 2 choices, first derivative test or the second one. You look at the function. You see this is the derivative. If you want to use the second derivative test, you have to differentiate this one again and then substitute 25 and check the concavity. If double prime is positive, It's going to minimum, it's a negative, you get a maximum. Or get the chart for f prime. Get the chart for f prime to find out where the f prime is positive or where the f prime is negative. First derivative test, okay, my comment is this one. First derivative is easier because this e function part is always positive. So you can forget it. So just check a couple of numbers here to find out, you know that you have to check where the function will be increasing or decreasing. So my suggestion is first derivative test for this one. Okay, but if you don't like it, you can use second derivative test, which is not a good one. Okay, so the first derivative, you have to give us a chart. X. The domain of the function is set of positive numbers only. And you have one number to test, 25. So you have to test the f prime. F prime of x. F prime of x is 0, that's 25, because 25 is a critical number. So this is going to be your f of x. And the only information is that this is going to be 75,000 divided by e. So you have to determine the sign of the f prime in two places. So you have to pick two test numbers, and you have to show your test, test numbers. So you have to pick one number between 0 and 25, and one number between 25 and positive infinity. And you drop it into the f prime. So this is going to be your f prime, you see. Your f prime of x, I repeat it, is e to the negative 0.04 x times it by 3000 minus 120x. You have to test it here. But this is positive because of the e. So we can only test the number here in 3000 minus 120. It's easy. If you test 1, if you replace the x by 1, that gives you 3000 minus 120, which is a positive number. So that would be positive and the function going up. A number in this part, okay, a number like, if you check 100, for example, you can pick any number you like. If you put 100 over here, this is 120. So that would be 12,000 and this is 3,000. 3,000 minus 12,000 would be a negative number. Negative. The maximum. You see? That's what you do. You can write it down, those numbers, but it's clear that f prime of 1 is going to be, as I talk about it, this is the positive. And the inside would be 3,000 minus 120. So that would be a positive and a positive. So the result is positive number. And if you check the 100, the outside is positive. The inside would be 3,000 minus 12,000. Okay, which is going to be, this is positive, this is negative, so the result would be negative. So as you can see, f of 25 equal to the 75,000 over e is a maximum. And since this is a relative maximum, but since there is nothing else to compare, so this is absolute, absolute maximum. So the final answer would be the maximum. This is absolute. F of x is 75,000 over e. And you are done. It's a very popular problem, in this concept, if you like. And it's easy function. But the way the people they do it, they miss the u prime here. You see, when you differentiate it, this is where they missed. The derivative of exponential function is exponential function. And you always have to multiply by u prime. U prime is the derivative of the top, which is the negative 0.04. Just make sure don't miss this one. Otherwise, the rest are going to be just straightforward. Okay, any question? So that is optimization problem in the case of the exponential function. Okay, one exponential, one ln function. We give you one from each. So that was number 2. Now we have for the natural log function, it's number 3. We give you 2 options over here and give you something similar to this group. Okay, so we're going to take the number 3 to see how we're going to handling the same type of problems, but for the ln function. Okay, I think I did the first one, but I do it again. It's f of x. There are a group of functions like this, so we wanted to see it. You see, this is going to be your function. Of course, they give you the domain. Domain must be positive numbers because ln function is defined for the positive numbers only, but they give you the domain. So this time they ask for absolute minimum of this function. Okay, absolute minimum. So the same thing, you have to differentiate it. Let the derivative to be equal to the 0. Find your critical number. You drop back the critical number into the function and then test it. Whether either you are going to use the first derivative test or the second. Okay, so that's a procedure. So previously you did it for the polynomial function. Now you are going to do it for the exponential function. Okay, so that's why on the final we usually give you this type of problems for the max and the min. Okay, we differentiate f prime of x equal to div of x squared with the 2x minus. It's 8 times, so it's not a product rule. It's going to be 8 times the derivative of the ln function. The derivative of the ln function is 1 over x. Okay, so 8 times 1 would be 8. So this is going to be 2x minus 8 over x. That's going to be your f prime. Okay, any question? So this of x squared 2x, derivative of the ln x 1 over x. Let it equal to 0 to find your critical number. So f prime of x equal to the 0. This means the 2x minus 8 over x. Okay, 8 over x equal to the 0. We want to solve this equation. We did this type of equation before. You have to get rid of the denominator first, okay? So one way to do it, you can multiply both sides by x, okay? Or since it's only 2 terms, you can move one of them to the other side and use cross multiplication, okay? So you have 2 choices. So you better do this one. Some of you missed this equation on the test, on the quiz, because there was one, okay? And you can think about this one as a 2x over 1 and then cross multiply. When you cross multiply, so that gives you 2x squared equal to the 8. Okay, we saw for the x squared would be what? 8 divided by 2, which is 4. Now we take the square root, x would be positive negative 2. But you note that the x is positive because using ln function. So x is positive. So this means you are going to pick only one solution, x equal to 2. So your critical number is going to be equal to 2. Okay, on all these problems, you are going to have only one critical number. Okay, that's going to be on. Any question? So the next step is you drop this back into the function, then you test it, either the first derivative test or the second one, whichever you feel more comfortable. Okay, so we go back, we substitute. So it's going to be f of 2. F of 2 would be 2 squared minus 8 ln of 2. You may have to use your calculator. 2 squared would be 4. So that gives you 4 minus 8 ln of 2. Okay, you may use your calculator, but ln of 2 is 0.69. Okay, so it's going to be f of 2 equal to 4 minus 8 times 0.69. I'm going to call it 0.7. Easier, to work with it. It doesn't matter. It's going to be 4 minus 5.6. Okay, 5.6 So that gives something like negative 1.6 or something like this one. So f of 2 is equal to the negative 1.1.6. This is the one that you have to check it. Any question? So it's like, all the other problem that we did before, but we used to work with the polynomials only, but in this case, we are going to work with, exponential function and the ln function for the rest of the course. Okay, now you have to check it. You have to test it. Okay, we are interested in the minimum. You test it to see which one is it. Okay, so what tests are going to use for this one? Testing. You have the first or the second derivative. Let's look at the function. This is the function. F prime. See, I write the F prime. So you can use either the first derivative or the second one. Second one is easier for this one because it can be easily differentiated again. So I go with the second for this one. For the exponential function, the first, but for the ln function, the second. So I suggest the second derivative test. And the reason is that f prime of x, I can rewrite it. You see that's a 2x minus 8 over x. I can rewrite it as a 2x minus 8x to the negative 1. So I can differentiate it easily. So the derivative, the second derivative is going to be, if I have a 2x is going to be 2, negative 1 times negative 8 would be a positive 8, and the x to the negative 2 when they differentiate it. Then I get it back to the positive power. So it's going to be 8 over x squared. You see, it's already a positive number. Officially you have to drop the 2 into this function, but you can see that, even if you plug in the 2, so that gives you 2 plus 8 over 2 squared. You don't need this number. You just need to know that this is positive. Okay, F double prime give you the direction of the curve. Positive means it's curving upward. So curving up, you get a minimum. Okay, so F of 2 equal to the negative 1.6 is a relative or absolute minimum. E is going to be a mean. Okay, so the minimum value of this function is negative 1.6. Again, since it's a relative minimum, of course. It's a relative minimum, but you don't have anything else. You have only one minimum. Since you have only one minimum, you can call it absolute minimum. Means that the minimum value of your function is going to be negative 1.6. Any question? So that gives you kind of experience of how you're handling this optimization problem, maximum minimum. But in the case of the ln function, this is two groups that we're going to have. Okay, any question? We have another one. That part B, you may get involved by using your calculator. I do it for you too, because this is probably in your book. Okay, so that gives you an idea how we handle these type of problems. So I do a little bit of the B2. Okay, because there is one part that probably you may have some difficulty to operate, 3B. 3B, it's the same question, f of x equal to the x squared ln of x. Okay, that's the case. Again, the same thing, x is positive. You want to find the minimum. So you differentiate it. This time you have to use the product rule. You have to have the first times second, second first. Okay, so the f prime of x is going to be, the derivative of the first one would be 2x times the second one, ln x. That's the derivative of the first times second. plus derivative of the second times first, derivative of the ln x is 1 over x. So that gives 1 over x times the first one times x squared. But you get a chance to simplify. So that gives only x. So the derivative would be f prime of x equal to the 2x ln x. Okay, 2x ln x plus x. So that would be the derivative of your function. Okay, any question? Now you have to let it equal to 0 to get your possible critical number. So f prime of x equal to the 0. Then you have to solve this equation. You see 2x ln x plus x equal to the 0. To solve this equation, first we use factoring. We factor out the x, and then for the rest, we able to do it. So you factor out the x. So that gives you 2 ln x plus 1 equal to the 0. Again, either x equal to the 0. In this case, it's impossible because x is positive. Besides, you're using ln function. When using ln function, positive numbers only. So ln of 0 or the negative numbers doesn't make sense. So the second factor equal to the 0. Now you solve for the ln x. So that gives you 2 ln x equal to the negative 1. And then you find the ln x, which is going to be negative half. Okay, and then you have to find the x. And from algebra, we know that the x is going to be equal to the e to the negative half. See, this is what I was talking about. Just using your calculator to get these numbers. Okay, we solve for the ln x. Ln x would be negative 1/2. You know that the base is e, so we change it to the x equal to the e to the negative 1/2. You can keep it as is, or you can use your calculator from now on for the rest of the problem. If you want to keep it, you have to write it down in the positive format. It's going to be 1 over e to the half, and this is going to be 1 over radical e. If you want to not to use your calculator. So, but eventually for this problem, as I told you, it's from your book. I just wanted to see that if you have these type of problems, okay, it is not not a big deal. You can you can handle it. But some people they use calculator from now on. Okay, so it's going to be x equal to the 1 over e to get this number. Okay. So the one that we are going to give you is going to be something that you don't need a calculator, but this is also not a big deal if you want to use it. Okay. Any question? Now, so we have the critical number. This is going to be the critical number. You have to drop it back into the function and then test it. Again, dropping back to the function, you may use your calculator or just this one. So this is the function x squared ln x. So if you substitute, it's going to be f of 1 over radical e is equal to x squared is 1 over radical e all squared. Okay, then the ln of that 1 over radical e. You square the first one, that give 1 over e. Okay, 1 over e. And this one, if you go back to the e to the negative 1/2, it would be negative 1/2, or just using your calculator to get this number. Because 1 over radical e would be just e to the negative 1/2. You bring the negative 1/2 down, and that give you the result. Or just use your calculator. So f of 1 over radical e would be negative 1 over 2e. You may prefer the calculator to get these numbers. Okay. So this is your candidate. Now you have to test it. You have to test it. You have to decide which test is going to be better. The first or the second one, you see this is going to be your F prime. Both of them would have enough work to do, okay? You can, if you want to use the second derivative test, you have to differentiate again. Or you can leave it as is, just use calculator to identify the sign of the F prime. So I use the first derivative test. Okay, so it's going to be testing. I'll go with the first derivative test and I use calculator. So I have F prime of X, which is 2X ln X plus X. Okay, so you have to give a chart. X, domain 0 and positive infinity. The number that you want to check is something like 1 over radical E. Okay, and this is going to be an F prime. Okay, this is going to be F prime. And F prime is 0 here. The result is negative 1 over 2E. And this is going to be your function. Okay, so you need two numbers in this two area to get it. What's going to be those numbers that you have. Okay, and just check the sign of the F prime, which is you see it's going to be F prime. F prime of X is equal to what? Is equal to the 2X ln X plus X. You see two numbers to check for the numbers. The easiest number for this one, again, your calculator, you have to check two numbers. You need a small number here. Okay, so something between 0 and 1 over radical E. So just try to avoid the calculator, but it's not going to be possible to get these numbers. Okay, so let's see if we can make something. If you want to have something easy, you get something like you can take 1 here, very easy, because ln of 1 is 0. You see, if you put the 1 and use your calculator, F prime of 1 would be 2 ln 1. 2 ln 1 plus, okay, plus 1. ln 1 is 0. So that gives you 1, which is positive. Okay, so that would be positive. Then you can pick some numbers here. Okay, it's 1 over radical E. You must have something like, a fractional 1 to get. The numbers is going to be down something like, if you pick, because that's a 2.7. Okay, so if you pick something like a 1/5 and put it in your calculator, probably you will get a negative number here. So that would be negative, so it's going to be down, up, and you get the minimum that you are interested in. As you can see, because the numbers are not just straightforward, so you have to use your calculator if you want to do it, and to get to finish it. So just your calculator, you get the negative sign here and the positive sign here, so the function would have a minimum. So the minimum value is negative 1 over 2E. Yes, what's the question?
I was wondering, like, is 2X ln. Do we put another 1 in there?
It doesn't. 1 is 2 times 1 is 1 is 2. It's there.
Okay, yeah. Okay, sorry, I just wanted to see it.
Which is 1.
Okay.
Okay, so that's 1. Any questions? So as you can see, you've got to be, patient. The one that we are going to give you is something that, the result would be nice, but it's not bad in case, in practice, you have to deal with this type of function. This is the way you're going to, okay, we are going to operate it. Okay, so that gives you enough information to find out how we're going to handling the optimization problem for the exponential function and the ln function. Okay, this is number 3. Number 4 is similar to the one that I did. If I get time, I'll come back and I do it for you. because f of x is 4x e to the negative 2x, which is like the first part. So I go with the number 5 first. 5 is one of the problem in your book. Again, it's not a difficult problem, but this is, again, we want to use your calculator. So we give you one about the rate of change. And this is, again, that famous function that I talk about it several times. So that's why we brought it up again. Okay, so look at this one. Because it depends, it doesn't matter which discipline are you going to be. So you may have to deal with the rate of change. Remember, rate of change means derivative. So especially when you're dealing with the exponential function and the log function, it's very important to get this type of problems. So it's just using calculator and one derivative. Once more, you see this famous function. So what's question number 5 about? You see, we are checking, what is that? Somebody will have a drink, okay? You know that the alcohol would be in the blood for some specific time. So the mathematical modeling of this procedure is already given to you. So this is going to be the function. F of t equal to the point 23, okay, t e to the negative, see, like the one that I did, 0.4 t. This function is given to you. What is this function? This function, this is the percentage of alcohol in a percent blood t hours after drinking 8 ounces of whiskey. Okay, so it's going to be t hours later. So if somebody has a 8 ounces of a pick of whiskey, if you like, after 3 hours, this would represent how much alcohol is going to be in the percent blood. Okay, so there are, for each phenomena, there is going to be this type of function. Okay, put money in the bank, growth of the coronavirus, etc. So what we would like you to do is, would like you to answer 2 questions for us. The first question would be related to the function. The second question would be related to the derivative of the function. So what is going to be the first question? Remember, this is the percentage of alcohol in the percent blood t hours later. Okay, so what's the first question? The first question is, what is the percentage of alcohol in a percent blood after half an hour? Easy. After half an hour means t is equal to the 1/2 hour. So what you would like to do, you would like to find the amount of the alcohol. So you want to find f of 1/2. Okay, go to the function, substitute, use your calculator to get f of 1/2. So what is going to be f of 1/2? F of 1/2 is equal to the 0.23 times t. What is t? T is 1/2. 1/2. Okay, e to the negative 0.4 times t. T is going to be 1/2. That's it. So you simplified. Use your calculator. Give us the percentage if you like. So this is what can we do? So this is going to be simply, we cannot simplify. It's going to be 0.23 divided by 2 e to the. Okay, you can simplify this two, that give you 0.2. Okay, use your calculator if you have one. Just give us the number. What is going to be this one? I'll try it myself. Okay, it's a negative 0.2. So then I'm going to multiply it by 0.23. divided by 2. Okay, anybody got the answer? Or this one? What's going to be the percentage of the alcohol in the body?
9.4%.
Excellent. Yes, 9.4% is correct. Okay, anybody else? Yes, about 9. Yes, 9.5. Yes, yes, that's going to be the result. You see 0.094. This is going to be the bond. Okay, so it's going to be 9.4% almost. So this is going to be 9.4% or just 9%. We accept that. So that's going to be half an hour later. So there's going to be an amount of the alcohol in the body. Any question? So that's one half hour, and then they say after 8 hours. Okay, so it's going to be just after they having it, if you like. After 8 hours, so the second part is going to be t equal to the 8 hours. Okay, so we are going to go to the function again, and we replace the t by 8. So f of 8 is equal to the 0.23. This time times 8 e to the negative 0.4 times 8. Okay, then we can use calculator or just, let's separate a little bit. 8 times 3, 24. And that's going to be 16, 18. So far I have 1.84. And this is going to be e to the, that would be 3.2. Okay, 3.2. Again, if we use the calculator to get this number. So we start with the E, which is going to be negative 3.2. Okay, then times it by 1.84. Okay, do you have the answer for this one? Anybody? Just checking. How many percent? I have it, I just want to double check. See, yes, Charles, we are right. 7.5% is right one, yes. And Rosa, you're right. Yes, you know that after a while, the alcohol from the 9%, after 8 hours, it must be much less. Yes, this is going to be the case. Okay, 7.5%. So it's going to be 7.5%. Okay, after 8 hours. So the amount would be reduced, if you like, after a while. Okay, not exactly after you have it. So that's going to be 7.5%. Okay, any question? So that is the first part of the problem. The first part of the problem. Again, we create something similar and we ask you, but the second part, so this first part is algebra, if you like, okay? So we get the function and we substitute to get the numbers. Second part is calculus. So what's the second part? The second part is how fast is the percentage of the alcohol in the person's blood changing, after half an hour or after 8 hours. You know that how fast, what's that? How fast is the speed, is the rate. Okay, so when they say how fast, that means the derivative. You see, they say how fast. How fast means F right. It's a rate. They want to know the rate of the, okay. You see, you remember we talked about it. When we talk about f prime of 10, the definition of f prime of 10 was what? After 10 hours, whatever it is going to be increase, decrease at the rate of, so it's going to be the same thing. So how fast after half an hour. This means in the second part, they ask for the f prime of 1/2. Okay, and they ask for the f prime of 8. We know that the alcohol percentage would be reduced, would be decreased. So we want to know at what the rate is going to be the case. Okay, for the rate, you have to differentiate it. And see, I told you this type of function is very important, and you have it. So it's like the question number 3 that we did, 3000 x e to the 0.4. We have to differentiate it. Okay, so we bring up the function and carefully differentiate it. So this is going to be the function. You see, this is much better than any other question that we can discuss or we be given to you. So that's it. Differentiate it first. You have to apply the product rule. Okay, derivative of the first times second, second first. This is going to be considered to be first. Okay, and this is considered to be second. Okay, carefully differentiate it. It's not a big deal. We get some decimals. Okay, take care of the decimals. Derivative of the first one would be just 0.23. Okay, 0.23, the first one times the second one, which is e to the negative, 0.4t. That's the derivative of the first times second, plus the derivative of the second times first. The second one is exponential function, as we did it before. Exponential function never change. Okay, it's going to be as is, but we have to pay for it, u prime. U prime is going to be negative 0.4. Okay, but make sure you multiply by the first one, which is going to be 0.23t over here. Okay, any question? So we just differentiate using the product rule, derivative of the first times second, second first. Now, if you put them together, that give you f prime of t. F prime of t is equal to the what? Is going to be 0.23 e to the negative 0.4t. Okay, that is going to be the one. And if you multiply these two together, so that's going to be minus, minus 4 times 3 would be 12. And 4 times 2 would be 8, 9. So that give you 9. Okay, it's going to be 9, but you have 3 decimals. So this is going to be 0.092. 92t times e to the negative, 0.4t. Okay, that is going to be the case that we're going to have. Okay, so this is going to be our f prime. It's going to be f prime. You can keep it as is and go for it, or you can, you can factor out you can factor out, if you like, that e part, or even 0.23. You're just using calculator, so you'll be fine. But the option is, if you like, the option is going to be, that would make it easier to handle it, or just leave it as is. I don't mind. So if I could factor it here. If I factor out 0.23, so that give me 1. Okay, it's going to be 1 minus 0.092t. Okay, it's going to be the same. If you want to find the critical numbers, you do this type of operations. But otherwise, you can keep it. But this is going to be the case. But you have to drop the numbers again to check this one. Okay, it's going to be f prime of 2. You have to find f prime of 1/2 and f prime of 8 to find the rate. Okay, so either factor it or not, it doesn't matter. So I go with the f prime of 1/2 first. F prime of 1/2 is going to be 0.23 e to the negative. Okay, we did this one before, so it's going to be 0.2. Okay, that gives you 0.2. Okay, when you substitute, so it's going to be 1 minus 0.0. I made a mistake probably. when I pull out the 0.23 out, so I should have only, you see that's one. I should have only, sorry, this is, if I factor it out, I should have only 0.4. Because, you know, we multiply by 0.4 to get it out. So it's going to be 1 minus 0.4t if you factor it. Okay, so I factor out 0.23 e to the negative 0.4. So that gives me 1 from here, 1 minus 0.4t. Okay, 0.4t. So it's going to be 0.4 times the 1/2, which is easier to handle. But you know, it depends if you like it or not to get these numbers. Yes, you know, you are right, George. I find out that I made a mistake over there. Okay, now use calculator to get this number. Okay, and we have almost a little bit of this number here. Okay, because we divided by 2, so it's going to be, we'll just use calculator. It's going to be 4.7, this one, because this is okay, 0.94, and so this is going to be 0.23 e to the negative 0.2, and this is going to be 1 minus 0.2. 0.2 is like a 0.8, or calculator, 0.23, okay, e to the negative 0.2, and this is going to be 0.8, okay, and eventually we get this number. Okay, so I think this should be this one. This the first one must be 0.47 and times the 0.8, so 56, 32, 37 with 3 decimals. I think is a 37.6%. Without calculator, you know, we can use it to calculate to see if it's going to be the same number. Okay, just double check this one. We give you, you know, the not 2 numbers if it's going to be the case. Then which one do you want? So this is the one that we did. You see, that's 1. We find the first part, and then this is going to be, so this means after half an hour, this is going to be the rate that you're going to do. You got 15%. 15%. Did I miss anything over here? So it's a 50.23. I'm going to check it. So check these numbers. Maybe I made a mistake. 56, 32, 37. Okay, I'm going to check it. 0.23 times it by, that was the E to the negative 0.2. So it's a 0.18. Now times it by 0.8. Yes, you are right. 15%. Yeah, you know, double check it on yourself with your calculator. So I take that 15% or 0.5. Okay, that would be 15%. Yes, you are right. I got it, the same thing. Okay, so so this means after half an hour, you see, after half an hour, that the rate that you are going to have, okay, percentage is going to be 15%. How fast is the percentage of alcohol changing after half an hour? and that would give us the final answer. That's going to be 15%. And then you can do the same thing for the 8. Okay, so we can do it if you get time, that. Check that one too. I give a break. We come back. I do the integration first because I want to make sure you get those numbers done. And 2 application problems for the corrosion decay. And then, then we check the leftover if you get time. But this is just give you an idea. If we give you one of these, I have a couple of these mathematical modeling, but we make it just one number, not 2 numbers like this one. So just locate where your calculator will give you exponential function, okay, because this is part of the deal that we have to show you how we're going to do this type of operations in case you need it. Okay, it's 8:23, 10 minutes. I come back, I do the integration first because we give you 2 problems on the integrations. Okay, see you in 10 minutes. Okay, let's take a couple of these problem on the integration first. Is the number 8 and the 9. We give you 2 questions on the integration. Remember, the integration is just the opposite operation. The derivative of the function would be given. You want to recover the function. So the action is this one. You need only this formula. Okay, so that's number 8. You need only to know that integral of, and that's it, x to the n dx. You want to find a function whose derivative is given to you. Action of integration is the opposite. We add to the power x to the n plus 1, and we divide. In the case of differentiation, you reduce the power, okay? You multiply the exponent by the coefficient, and you reduce the power by 1 unit. In the case of integration, we do the other way around, plus the constant c. Okay, this can be done all the time except when n is -1. So n cannot be equal to the -1, because otherwise you cannot divide by 0. So what we're going to do if it is the power is a -1? So this would be, we change it into the 1 over x dx. And we know that if you want to find a function whose derivative is 1 over x, that function is a natural log function. It's going to be ln x, but we talk about it, you must write it on the ln of the absolute value of x plus c. Why? Because this function, 1 over x, the domain of this function is all real numbers except 0. But ln x can be defined only for the positive numbers. Okay, this is the only formula that you need to know for the integration. So you have to have a power here. So if there's going to be a radical function, we change it, exponential function, exponent. If you do the rational function, we change it, as we did for the, okay, for the derivative of the function. So question number 8, we give you 2 integral to evaluate for us, okay? So these are going to be the candidate. So let's take one by one, part 1. You want to find the integral of 5x to the 5th plus 2 radical x minus 1 over x dx. So first thing to do, we change to see if there is any radical. You switch it. If it's going to be any rational function, any x here, if the power is 1, you keep it as is because the result is a natural log. If any other power, you move it up. Okay, so your first job is rewriting. So this is the original one, 4x to the 5th plus 2 radical x minus 1 over x. I rewrite it, you don't have to. So it's going to be integral of 4x to the 5th plus 2 radical, you change it, x to the half, minus, since this is 1 over x, we keep it as is. Any other power, we move it up. Now we integrate one by one. This is the only formula that we have. So for the first one, like differentiation, we keep the 4, then x to the 5th, add 1 power. It's going to be x to the 6 over 6, done. The formula. Next, you keep the 2 and you add x to the, this is 1/2. 1/2 plus 1 would be 3/2. Divided by the 3/2, done. Minus 1 over x. Integral of 1 over x is ln x, ln of the absolute value of x, but we always add the constant c to get the general solution. You have to get rid of these numbers. You simplify it if you can. So this would be simplified by 2. So that gives you 2, that gives you 3. So this is going to be 2/3 of the x to the 6. For the rational number, we use the reciprocal. It's going to be 2 times the reciprocal of the 3/2, which is a 2/3. Okay, x to the 3/2. And you cannot do anything with the others. So again, 2 times 2 would be 4. So this is going to be 2/3 x to the 6 plus 4/3 x to the 3/2 minus ln of the absolute value of x plus c, and then you're done. In your final answer, we don't accept any negative power. So if there is any negative power, you flip it into the positive power. Otherwise, we accept these rational power. Any question? So we got to be careful, the only job is changing these radicals really. The rest are going to be straightforward, but that is number one. The one that you will see is going to be just a couple of radicals and the fraction. So another one, integral of 2 over cube root of x plus x to the 3rd plus 7 e to the x dx. Again, you want to integrate, you have to change this one. It's a cube root of x, we change it to the x to the 1/3. Right? It would be down the denominator, so we move it up, x to the negative 1/3. So this is going to be the conclusion. Rewriting is going to be 2x to the negative 1/3. Okay, because cube root of x would be x to the 1/3, and you move it up, plus x cubed plus 7 e to the x. Now we are ready to operate. 2 is a number, add x to the negative 1/3 plus 1 would be 2/3 divided by the 2/3, done. Plus add x to the 3rd would be x to the 4th divided by 4. Plus 7 exponential function never change, you know that. Derivative and the integral would be all the same. Integral of e to the x is e to the x, because derivative of e to the x is just e to the x. You have to take care of this one. It's going to be 2 times reciprocal, 3/2. 3/2 x to the 2/3, okay, plus x to the 4th over 4, and the 7 e to the x plus the constant c. You can simplify these two together. 2 divided by 2 would be 1. So the final answer, 3x to the 2/3 plus x to the 4th over 4, 7 e to the x plus c, and then you're done. Okay, so the extra job, algebra, that you have to reverse these radicals or these quotients. Otherwise, it's a routine operations. Yes, what's the question?
So for this problem, we moved the x to the negative 1/3 because that's just how it is. We never move the 1 over x like in the other problem, right?
Yes, that's it. Yes.
Okay.
You never move 1 over x. Everything else you have to move it. Okay. You never move 1 over x because 1 over x would be ln x. You see, anything else you have to move it. Okay. Any question? Now, this next one is also not bad. Then we get to the something more interesting. Okay, so that's going to be A, B. We give you 2. It's a 1 question, 2 parts on this test and 2 parts on the final. On the final, you get quite a lot of this type of problems. Okay, so let's see. C is just not bad. 10x to the 4th minus 8x to the 5th. Okay, minus 2 dx. Again, we have to move x to the 5th up. So it's going to be 10x to the 4th minus 8x to the negative 5 minus 2. You see? Now we are ready. Keep the 10 at x to the 5th over 5 minus 8 at x to the negative 5 plus 1 would be negative 4. Negative 4. And the 2. You see, it's like negative 2x to the 0. When you add would be 2x, negative 2x plus the constancy. Okay, for the constant number, it's going to be 5x, 2x, 7x. Do the simplifications, the 10 divided by 5, that give you 2. So that give you 2x to the 5th. Over here, negative would be positive. 8 and 4, we can simplify it. Okay, so we simplify this one. So what we're going to do is, this is going to be negative would be out, so it's going to be a positive fraction. On the top, 8 divided by 4, which is 2. Negative power, you have to bring it down back. Okay, we don't leave any negative power into the, okay, into the final answer. So it's going to be 2x to the 4th. Okay, negative 8 over negative 4 would be a positive 2. And x to the negative 4, we bring it down with the x to the 4th minus 2x plus c. And you're done. Any question? Extra job is only this one. Now, something different is the next one, part D. Let's see what is special about this one. Part D, you see you have 12 plus 5x, okay, plus 5x minus 3x squared, sorry, x cubed, divided by x to the 4th dx. Again, you see, x to the 4th, you have to move it up. But you got to be careful the way you are going to write it down, this one, when you move it up. You see, this would be, move it up, it's going to be x to the negative 4. But you have to open up the parentheses. Most of the people, they miss this one on the test. They don't open up the parentheses. In that case, they multiply only x to the negative 4 by 12. But when you put the parentheses, you multiply it by all of them. Okay, so it's a big difference between these two type of operation. Okay, any question? You have to move it up and multiply by everything on the top, everything. So that's why we put the parentheses. Now we multiply the inside, 1 by 1. So it's going to be equal to 12x to the negative 4, the first one, plus 5x to the what? You see, this is the negative 4, the power is 1. When we multiply, we add the power. Negative 4 plus 1 would be negative 3. Okay, minus 3 x to the, this is a negative 4 plus 3 would be a negative 1. You see, that would be the conclusion. Any question? So move it up. Yes, we move it up, but you have to open up the parentheses so that you multiply x to the negative 4 by anything inside or everything inside. When we multiply, we add the exponent. You see, this is a negative 4, the exponent is 1, so negative 4 plus 1, negative 3. Negative 4 plus 3, negative 1. Now we are ready to integrate it. The integral 12 add x to the negative 4 plus 1 would be negative 3 over the negative 3 plus 5 add x to the negative 3 plus 1 would be negative 2 over negative 2 minus 3. Now this is interesting now. X to the negative 1. Remember, for the negative 1 you cannot add because that gives negative 1 plus 1, which is 0. But we know that x to the negative 1 is like 1 over x, and this is the derivative of the ln function. Okay, ln of the absolute value of x plus the constant c. So be careful. You are going to get, they arrange it so that when you simplify it, you will get to the x to the negative 1. And automatically you find out that we cannot do the power rule because negative 1 plus 1 would be 0, and you cannot divide by 0. But we know that the x to the negative 1 is like 1 over x, and the integral of 1 over x is the ln x. We have to simplify it and no negative power down the denominator on the top. So you simplify these two first, that give you a 4. Okay, so what we're going to write it down is going to be a fraction. Since there is a negative sign here, so the fraction would be negative. You get the 4 on the top. You bring the x to the negative 3 down, make it to the x cubed. You have to get back to the power, positive power for this number. Any question? Okay, here we cannot simplify. The sign would be negative. A fraction on the top would be 5. Down the bottom would be 2 times x squared, because you bring the x to the negative 1, negative 2 down. The rest are going to be just as is. Okay, so there's algebra involved, and be careful when, on the first part that you move up this denominator up, you do the simplification by multiplying, adding the exponents, then do the integrations, and then come back to the original format. Any question? That's the only one which is different from the other one. All the other are almost like each other. Okay, question? So that's E. Again, you have the E, that was the part E. Part E, because of these radicals. So 5 radical x. And you have some very nice one, that take-home one that I posted for you. It's a very good one, very useful. So do that one to practice. It's a 5th root x to the 3rd dx. So you have a job to do first. You have to remove all this radical. Okay, we remove the first one easily, x to the half. We remove this one. It's going to be, when it's done, the denominator is x to the 3/5, but you have to move it up. So negative 3/5, okay? So if you rewrite it, the conclusion is going to be this one. It's going to be 5x to the half, okay, plus 6x to the negative 3/5, negative 3/5. Okay, patiently, just, reverse it, rewrite it. Any question? Now operate. We keep the 5, add x to the 1/2 plus 1 would be 3/2 over the 3/2. Okay, plus 6 times x to the add. It's going to be 3/5 plus 3/5 plus 1, which is going to be 2/5. Okay, you know that it's a 3/5 plus 5 would be 2/5 divided by the 2/5, and of course the constant c. Change these fractions, flip them, reciprocal. Okay, 5 times. This would be 2/3 x to the 3/2 plus, this would be 6. It's going to be 5/2. Okay, x to the 2/5 plus c. I just use the reciprocal and just said simplify if you can, or otherwise write it as a fraction. 5 times 2, 10, 10/3. 10/3 x to the 3/2. Okay, then over here, you get a chance to simplify. That is 1 and that's 3. So it's a 3 times 5, 15. That gives you 15 x to the 2/5 plus the constant c, the final answer. Any question? So these are kind of the VIP one, we get algebra involved, but double check when you do this fractional one, and you'll be fine. Okay, that's a part E. And after your test, there is one more method. We talk about it. We get quite a lot of, okay, like the chain rule type of problems, but not now. Okay, part F is again the one that you have to move it up. Any question? Are you done with this one? So the last part of this question. Again, check the similar one on that take-home one. And we give one question, two parts, two of very similar of these. You have all the possibilities here. You know, it's a very good one. Okay, so finally this is 2x squared minus 5 divided by x to the fourth dx. And you know what to do, you have to move it up. Okay, we move it up, right on it's x to the negative 4, but we multiply by the top. So it's going to be integral of, it's x to the negative 4, okay, times it by the top, which is going to be 2x squared minus 5, and the dx. Again, you have to multiply inside, okay, term by term, and add the powers. So it's going to be equal to the integral of 2x to the, is the negative 4 plus 2 would be negative 2, minus 5x to the negative 4 dx. Okay, when we multiply, we add the exponent. Now we are ready to operate. That's going to be 2 times. Okay, 2 times what? X to the, it's a negative 2 plus 1 would be a negative 1 divided by negative 1. That's the first one. And this is going to be minus 5. X to the negative 4 plus 1, negative 3 over negative 3, and the constant c. Take care of those negative sign, negative power. So it's going to be equal to, you get a fraction. Okay, the fraction, this is going to be just a negative sign of the fraction. We keep the 2 on the top, you bring the x down, negative 2x. And over here, negative would be positive. You get a fraction, on the top we get the 5. On the bottom we get 3x to the third, plus the constant c, the final answer. Okay, just, you know, just a couple of them like this, number f, you have to do extra job. See, that's always the case for all these problems. Rewriting, you know, changing those radicals or the fractional one, otherwise it would be a nice one. Any question? So that is the first group, or one question for this type of numbers. Yes, what's question?
So I just want to make sure so if it's on the bottom, you add to the top.
You move it to the top.
Okay, so like negative 5x to negative 3, it was from negative 4. So if it's negative, you move it down. 1.
Yeah. When you're done, yeah, you bring it back. Yes. At the beginning, you say at the beginning, you move it up
Mm-hmm.
to be able to do it. But at the end, you have to bring it back because we don't accept, you know, this is not nice if you want to leave it. Okay, that's why I just moved this one down. You see x to the negative 3, yes, x to the third, x to the negative 1, the x to get this number. Okay. Now that's going to be the first one. Now what's going to be the second problem is just a kind of application of these. And we talk about it, this is like a derivative of the function, but we give derivative is rate of change. It's the speed, velocity. Derivative would be given, you want to recover the function. These are the function. But we usually have a constant c here because derivative of c is 0. So this is many functions. You can replace the c by anything you like. But if you are going to be interested in a specific one, you have to give us one condition because we need one equation to be able to find the c. So that's a second group of this problem. Okay, so in this problem, it's kind of application types. The notation would be different, but you'll be given the chance to find this c. Okay, so it's a number 9, and that's your second question on the integrations. So they ask for two function with this condition. Okay, the function is y equal to the f of x, and the condition for the part 1 is this one, dy dx. Dy dx is the same as the f prime or y prime, whichever you like. So dy dx is given to you, which is equal to the 3x squared plus 6x minus 2, that's your f prime, and with one condition that f of 0 is equal to the 6. You see, d by dx is the derivative, is the velocity, and this is the kind of initial position. So to solve this type of problem, change the direction first, and change the notation first. Replace the d by dx by f prime. So this is going to be f prime, which is a 3x squared plus 6x minus 2. So derivative of the function is given to you. You want to find the function, you have to integrate. So this means f of x, going back, is integral of 3x squared plus 6x minus 2 dx. Okay, in this problem, you have to set up the integral yourself. In the previous problem, the integral was setting up and gave it to you. But over here, you have to do it yourself. From now on, just integrate. There's no fraction, no radical, just go for it. So it's going to be equal to, you keep the 3, you add x to the third over 3 plus 6, we add x squared over 2. Okay, and the 2 we talk about is going to be negative 2x. But the constant c again. Okay, simplify it. So your f of x that you are looking for is going to be x cubed. These two would simplify to give you 3, so that gives you 3x squared. Okay, minus 2x plus c. So that's your f of x. But since you got the c here, it's not one function, it's many, many, many functions. Okay, because you can put c equal to 1, c equal to 2, c equal to 3. But they give you a second condition. The second condition is this function must satisfy this condition, f of 0 equal to the 6. So we can apply f of 0 equal to the 6 here to find the c. Okay, you say, oh, but I'm not done because I have f of 0 equal to the 6. So this means you go to this equation, you replace the x by 6, x by 0. Okay, so replace the x by 0 and you let it to be equal to the 6. Okay, so if you replace by 0, so that what? It's going to be all 0 plus c equal to the 6. So c would be 6. See? So in order to that condition, the second condition, satisfy your c is 6. So the function that you are looking for is f of x equal to the what? X cubed plus 3x squared minus 2x plus 6. So this is going to be your function. Any question? So they call it differential equation in every field, chemistry, business, physics. So in the other problem, we find a bunch of functions, you see, because of this constant c. But in this problem, we get a unique solution, we call it, because there is only one function that satisfies f of 0 equal to the 6. Okay, so we're checking your understanding of this concept. Okay, this concept that you have to integrate, okay, to get your f of x, and the fact that you are going to end up with a c, and since this condition is given, you are able to find the c. Okay, any question? So this is going to be again 2 parts, because we want to check that's a polynomial. We want to check one of those fractional one too. Okay, so checking the second part, we may give you 1 or 2, but as one question, we want to check it because this would be given to you on the final again. Okay, so the part B, a very mild fraction. Okay, so what's a mild fractions? The condition is dy dx. Okay, dy dx is equal to the 3 over x, okay, plus the 1 over x squared. But the condition is that the f of 1 is equal to the negative 1. Okay, so this is another format. So what we're going to do, we change the direction first. Okay, this is rate of change. You call it f prime. So the function is going to be f prime. F prime of x equal to the 3 over x plus 1 over x squared. Okay, that's going to be f prime of x. So to get the f of x, we integrate. So f of x is going to be equal to the integral of, okay, it's going to be integral of 3 over x, okay, plus 1 over x squared, all dx. Any question? Now you have to find this integral. That's what we want to check. It's a fraction, this is x, you are not going to move it up. But this is x squared, you move it up. So it's going to be equal to the integral of 3 over x, okay, plus x to the negative 2 dx. Okay, that's going to be the one. Any question? Now we integrate it. This is 3 times 1 over x. We know that. That gives us 3 ln of the absolute value of x. We talk about it when the denominator is x. We never move it up. We keep it as is. And that gives us a 3 ln of the absolute value of x. And the next one is going to be plus x to the, it's a negative 2 plus 1 would be a negative 1 over a negative 1. Of course, plus the constancy. Okay, so we carefully differentiate it. Since we get the x over here, so 1 over x would give us the ln x, ln of the absolute value of x. And the x to the negative 2, that gives you a negative 1 over. So change these, okay? So it's going to be f of x equal to, it's going to be f of x equal to the 3 ln of the absolute value of x. This negative is a sign of the fraction, so it's going to be minus. On the top, we get 1. Down the bottom, we get the x to the negative 1. You bring it down. That gives you 1 over x plus the constant, plus the constant c. Okay, any question? So that's a general solution. Means this is many solution. But we have another condition. The condition that f of 1 is equal to the negative 1. So we are going to apply this, oh, but f of 1 is equal to the negative 1. So go back and substitute. So you put your x equal to the 1. So that gives you 3 ln of 1 minus 1 over 1 plus c, but this must be now equal to the negative 1. Negative 1. ln 1 is 0. If you forget it, you can check it with your calculator. This would be 0. Okay, so that gives you only a negative 1 plus c. Negative 1 plus c equal to the negative 1. So you solve for c. C would be negative 1 plus 1. So c would be 0. That's it. So go back and substitute. You are not done. Remember, you have to go back and substitute. So f of x is going to be equal to the 3 ln of the absolute value of x minus 1 over x, and the c is 0. So that gives you the function in question. A function with those two conditions that we talk about it. Okay, so that's going to be the integration one. And you get these numbers done. Any question? So that's it. This growth decay, I'm not going to give any question of the